So
That's harsh.
all right.
Well, James, you are a senior engineer at Hunt a Killer, America's #1 murder mystery subscription, where you focus on building software, immersive entertainment experiences that make subscribers feel like they're solving a real murder, which sounds real interesting. And today you're presenting on From Monoliths to Microservices. We're so happy to have you here.
Great. I appreciate you having me. I'm really thankful to be able to share, what I've learned over the course of the past couple of months with the community, and just very thankful for the opportunity, and appreciate all of the organizers taking the time to put on the talk. Even though we can't meet in person, we're still able to meet with one another virtually and share knowledge and share our passion for all things software development and computer science. So I'm just going to jump right in. As Lee said, I am James Chadwick. I am currently a senior engineer at Hunt a Killer. I focus primarily on our e-commerce system, but I do a lot of software development to support our gameplay as well. We'll get into some of that in a little bit, and I'll explain kind of what that all entails. As far as me and my areas of interest, I've actually been a big proponent of and very interested by microservices and microservice architectures for a very long time. I'm also a big proponent of domain-driven design, which those of you who are not familiar with domain-driven design, and I'll have a list of resources at the end of the talk. This is a wonderful book right here, Domain-Driven Design by Eric Evans. This kind of changed how I looked at developing software and modeling a problem domain in a way that I feel really took my software development skills to the next level. I'm also a big fan of framework design, and again, I'm going to plug another book right here. This is Framework Design Guidelines, Conventions, Idioms, and Patterns for Reusable .NET Libraries. This was published by Wiley many years back. I love this book because it teaches you how to develop frameworks that really allow developers to fall into the pit of success. I think a lot of us have had situations where we've tried to use a framework or a library or even just work in an existing code base, and it's been an absolute nightmare. And this book really kind of focuses on how you can go about making software or libraries and frameworks that developers not only find easy to use, but in some situations, for those of us who are maybe a little bit weird, actually enjoy using. And then one of my other areas of interest or focus, hobby, is requirements analysis. In my time as a software engineer, have never had a business analyst who's been able to give me clear, concise, functional requirements. And so after a while, I just decided to pick up some books and figure out how to do it on my own. And so that almost became a little bit of a pet hobby of mine, trying to figure out how to clearly define what a piece of software should do and how it should function. A little bit of background on me as an engineer. I started writing software, writing code in high school, probably circa 2001, 2002. I graduated with a bachelor's degree in computer science in 2008, and I've been in the software development industry ever since. Just now have a little bit over a decade of experience. I think probably about close to 13, 14 years experience. I am still learning new things every single day. I am still finding new things that I am very interested in, or that really kind of spark that curiosity for me. And it's an amazing line of work, or an amazing career to be in. Which I guess leads me then to the other question of, well, what is Hunt a Killer, this place where I work? So Hunt a Killer is, at first and foremost, an immersive entertainment company. So we are subscription based. Each month we ship our members, we call them detectives. We ship our detectives a box of physical evidence and clues. Each month we refer to that as an episode. And each episode is part of a 6-episode long murder mystery, which we refer to as a season. So over the course of 6 boxes, or over the course of 6 months, you'll be getting clues, or detectives will be getting clues to answer questions like, what is the murder weapon? Is this person a viable suspect? Is that person a viable suspect? What is the motive? All to the culmination of that 6th episode, where they actually end up solving the mystery. The image that I have here is the first episode, or the first box of a mystery we call Curtain Call, which revolves around figuring out who killed Viola Vane, who was an actress who went missing in the 1940s, only to have her body discovered in a trunk in the Cadence Theater in the late 2000s. One of the interesting things about this is also, in addition to physical evidence, there are a large amount of in-world websites, applications, and even conversational AIs that again support the immersion into this murder mystery. Whoops, looks like my little clicker here broke. That's sad. That was the first time I used it in quite some time. So what I'm going to be focusing on today, or what I'm going to be talking about today, is our e-commerce system. So this is store.huntakiller.com. This is where our detectives or customers can go to purchase a subscription. We also sell box sets of premiums, or box sets of seasons. Almost think like a box set of your favorite TV show on DVD. You can get all 6 episodes in one box, as opposed to waiting 6 months to get it. We also sell one-off premium experiences that are kind of self-contained seasons in a box. This e-commerce system is really going to be the focus of my talk today. So why don't we just go ahead and we'll kind of get on into it. I want to answer the question of well, what exactly are we doing at Hunt a Killer, specifically with this e-commerce system? Our e-commerce system was built on top of Nop Commerce. I'm not sure how many of you are familiar with it, but it is a e-commerce platform that is open source. It's built on top of .NET. There's a wide marketplace and ecosystem of different plugins and things like that that you can purchase to have various different pieces of functionality or enhancements onto the base product. And because it's open source, you could also, as an organization, build your own plugins to support anything that you need to do, whether it be something on the front end or something on the back end. And that's actually exactly what we as an organization did. We bolted on all of our integrations for third-party services, for example, our subscription management platform, our shipping platform, and all of our various other tools. We developed those as plugins and kind of bolted those directly onto our e-commerce platform. And that went all very well for quite some time, up until maybe about 6 or so months ago, as our business really kind of began to scale and began to grow. And we began to kind of see, just like with any other monolith or just with any other application, the deficiencies in that approach. And so we've now decided that we are going to break up this monolith. We're going to begin to take these things that were bolted on, like our subscription management platform, our shipping provider, our different marketing tools, and we're going to begin to abstract those things away behind contracts that represent microservices, which provide a hunt-to-killer specific API or hunt-to-killer specific service, but wrap essentially our third-party providers. So then this way, the contracts for things like our subscription management service will never change when we decide to go from one subscription management vendor to another. So I got a little bit into this, but why exactly are we doing this? And I think this is because of some really kind of common scenarios and common use cases that end up getting seen in monolithic applications. We're doing this so first and foremost so we can better scale. The issue with a monolith is that when you need to scale a particular part of the monolith, let's say, for example, our shipping service or our shipping integration, you have to scale the monolith as a whole. You have to spin up multiple different instances of that monolith, as opposed to multiple different instances of the particular service in question. So if we have a surge in shipments that need to make its way from our e-commerce system into our third-party shipping provider, and we want to deal with that surge, then we have to scale the monolith as a whole. Also, kind of conversely, on the other side of that coin is if we have an unforeseen surge in traffic or surge in amount of shipments which need to go from our e-commerce system to our third-party shipping platform, then other areas of the application are going to suffer because that monolith as a whole is going to be serving every single request. And a lot of those requests in this instance we're talking about are going to be to ship boxes to customers. The other reason we want to do it is so that we can more easily make updates. With a monolith, if you decide to make a change or an update to a particular area or aspect of the monolith, then you have to redeploy the monolith as a whole. That can have impact across the entire organization. If that change were to introduce a bug or were to take down the entire or to take down some part, you're taking down your e-commerce system as a whole. So being able, or by breaking this out into individual different microservices, we can modify or update specific aspects of our ecosystem without impacting the ecosystem as a whole. That also has a lot of other benefits when it comes to project planning and project management and working with other teams in the organization. Some teams are very quiet and they have their way that they work, or they have their way that they use their systems and they never change. And other times there are lots of things which have to change and need updates very regularly. And so now, instead of doing many updates across across our e-commerce system as a whole, we're able to update individual aspects as they're required by different parts of our organization. The other reason we wanted to do this was so that we can actually own our own data. And this is a little bit of a mix of microservices architecture, a little bit of technical debt, and a little bit of philosophy or software development philosophy. But the way that a lot of integrations happen with third-party providers and things like that, you really just tend to fire off data to your third-party provider, and you don't really keep a log of what that data is. You may not even keep a copy of that data. So for example, in our legacy e-commerce system, when we wanted to integrate with Facebook and push customer behaviors and things like that to Facebook, we would just do that when it happened. We didn't tend to save any information about that interaction. We really just kind of captured that interaction and sent it off to Facebook and then kind of disposed the rest of the information. So in that situation, your third-party providers end up becoming the source of truth and the repository of your data. That can be a big problem if at some point later on down the line, you want to change providers. You want to go somewhere else and you want to take your data with you. I don't know how many of you have been in those types of conversations or in those types of situations, but there have been times where I have been in conversations with service providers and we have asked for copies of our data or we have told them that we are looking to switch providers and that we would like to take our data with us. And frankly, they told us, it's not your data, it's our data. You're not going to be getting it. So sometimes, if you're lucky, you can figure out ways to scrape that data or to pull that data down in some way, shape, or form through exports, and be able to honestly kind of reclaim it from a third-party provider who's holding it hostage. By architecting microservices or by creating microservices that act as wrappers around your third-party providers, you can store copies of that data itself before getting sent off to third-party providers, and then that ends up becoming truly your source of truth. That ends up becoming your data warehouse. That ends up feeding into things like business analytics and other type of business intelligence platforms and things like that. And you become less reliant on third-party providers being the source of truth or the repository of data for your specific company's data. I touched on this also a little bit in my previous statement about owning our own data, but the other reason why we're doing this is so that we can more easily swap providers. There are some instances where we have third-party providers who right now can really support us at the current scale that we're at and our current needs. But as we begin to grow and as we begin to scale, some of these third-party providers just won't be able to provide the amount of uptime or the amount of throughput or the request throughput or things like that we need. And so we need to be able to be open to explore the options of moving to other providers. That is not a difficult task in and of itself, but if you don't have a standard contract by which your other applications or by which your applications are integrating in with these providers or abstracting away the integration with these providers, then the changes to swap one provider out for another are pretty massive and pretty cumbersome and can end up affecting a lot of different systems. So by abstracting away the integration with these third-party providers and creating a microservice whose API is the contract by which applications will push data to those providers. You only really ever have to change out what's underneath the covers, the nuts and the bolts. I would very easily be able to swap out, for example, shipping service A or shipping provider A with shipping provider B, and none of my other applications are going to be the wiser. So what have we been learning during this entire endeavor? Well, the answer is it depends. And that's actually, as an architect, one of my favorite responses, one of my pretty much standard and go-to responses. A lot of times, not only the decisions that are made, but the lessons that are learned depend very much on context. There are lots of different things that will need to be taken into consideration in order to come up with the right decision. And once you've made the right decision, gain value and gain knowledge and gain learning from it. On the technology team at Hunt-A-Killer, we find ourselves a lot of times being very much engaged in the Socratic method. We try really hard to challenge each other's thoughts, challenge each other's solutions, challenge each other's preconceived notions or our assumptions or anything else that we come to the table with, not because we're trying to prove the other person wrong, or because we're trying to advance our solution or our agenda or anything like that, but because as a whole, we all have different perspectives, different considerations, different worries, different strengths, different areas of weaknesses, and things like that, that once we take into consideration, allow us to come to the best solution for the best or to the problem, given the best of our knowledge, the context of the situation, the landscape of where we find ourselves, and frankly the whole breadth of the problem. So what lessons can I share? This really kind of comes to the meat of my talk today. What kind of thoughts and what kind of insights can I share with you when going from breaking up a monolithic application into a set of microservices? Some of these lessons or some of these thoughts are not necessarily specific to the endeavor of breaking up a monolith into a microservice. Sometimes these are just general good software development practices or general best practices that I've learned over the course of my 12 plus years of software development. And they're things that, while they seem simple and while they're very easy to say, really are hard to embrace, hard to keep in the forefront of your mind, and really hard to really hard to remember or really hard to enact in the heat of the moment. You know, going back to Jeremy's talk or Jeremy's keynote, I find myself a lot of times getting very much caught up in the actual work, in the just sitting down and jamming out code and getting the problem solved. And lots of times I may say to myself, well, I'll just do this, or I'll just do that, or I'll leave a little bit of technical debt here, I'll leave a little bit of technical debt there. Every so often, I try to come back to these lessons learned and other lessons that I've learned through books like The Pragmatic Programmer and Clean Code and Clean Architecture, and try to say to myself, you know what, I might as well just do it now. So why don't let me stop rambling and let me actually get into some of the lessons that I've learned, or that we as a team have learned over the course of breaking up this monolithic application into multiple microservices. The first where I want to start is to think in terms of your organization. And what I mean by that is the microservices that you choose to develop, more often than not, end up tending to align to the organizational structure of your company or of your organization than they do different responsibilities or different aspects of the software that you're building. And a great example of this, I spoke earlier about our e-commerce system and how we were breaking out the subscription management, the shipping, and the marketing parts of that e-commerce system. Those all really end up falling into the different organizational structures of Hunt-A-Killer. Our subscription management service really tends to align with the wants and the needs and the thoughts of our customer service department. The requirements of our subscription management really tend to be guided by the things that either customers want to do, or the things that we don't tend to allow customers to do, but we allow customer service representatives who have training on the back end to do for them. Our shipping and our shipping service tends to align with the wants and the needs of our fulfillment team. They're the ones who are actually ultimately receiving the data of what information needs, or what packages or what products need to end up getting shipped to the end customer, and their requirements tend to be the thing which drives the requirements and the functionality of the shipping service. And our marketing service is very obviously closely aligns to the wants and the needs of our marketing team. When our marketing team decides to, for example, capture a new metric of customer behavior, or decides to integrate with a new service, for example, Facebook's conversion API, or a FOMO service, which, if you're not familiar, is for fear of missing out, which kind of broadcasts the fact that other people have purchased a product. Those things all align to our marketing service. And so as the marketing team identifies new pieces of new pieces of data around customer interactions, or new channels by which we can market, our marketing services requirements begin to become more elaborate and begin to change. The next lesson is to mirror the language of the domain, or mirror language of your domain experts. This this really is at the heart of it, domain-driven design. When you, I'll take a step back. A lot of times we as developers tend to really introduce new terms, or tend to name things differently than the way that our domain experts are referring to them. I have been in a lot of situations where a domain expert may refer to something as, for example, a shipment, but when I go into the code, I'll see it referred to as a delivery. And that really ends up hampering the interaction between domain experts and software engineers. Because as we're having a conversation, and as we are trying to come to an understanding about requirements or about the different entities and the different objects in our problem domain, there has to be this mapping that happens in both of our heads, which really slows down and hampers the conversation and frankly clouds understanding. So as I'm sitting there and saying, well, when a delivery gets submitted, we take the delivery and we do this, our domain expert has to sit on the other side and say, okay, well, every time James talks about a delivery, he's talking about a shipment. So I should think about a shipment. And more often than not, there are times where I may use a term that is definitely within the domain expert's lexicon or the domain expert's vocabulary and means something completely different to them than it does to me. So in domain-driven design, there's the concept of a ubiquitous language, a language that everyone from business analysts to domain experts to software engineers to users using the system all speak. And so as we're developing software, as we're developing contracts, as we're developing APIs and domain models and entities and all of those other things, mirroring the language of the problem domain and of domain experts really eliminates a lot of that confusion and makes interaction and makes, frankly, development a whole lot smoother. I'm going to take a moment here just to take a sip of my drink because I've been speaking for a very long time. Hopefully we can cut that out, but if we don't, I won't feel offended. My next lesson is to stand on the shoulders of giants. Far too often, we as developers and we as problem solvers try to end up reinventing the wheel. We're trying to think that we can build something in-house or do something better, or frankly, maybe even not be aware of the fact that a problem to a solution already exists. So when it comes to problem domains or even technical problems or technical frameworks or things like that, I have found myself now more often than not trying to ask the question of, is there a solution already developed for this? Is there a library that I can already use for this? Frankly, how can I make use of somebody else's time and effort? How can I benefit from somebody's 100 or 1,000 or 10,000 hours of coding and fixing bugs and testing and all of those other things so that I can get my solution or my ideas or my product out there faster? The next lesson I want to share is going to be a difficult one. I think about the meme about the scroll of truth and the hard truth that it ends up saying and then throwing the scroll away. And that's question the urge to invent abstractions. Ever since college and computer science courses or even YouTube courses on good software development, good architecture, it's been beaten into us to abstract, to consolidate code, to create these very rich inheritance hierarchies, and to try to really kind of consolidate everything as much as possible. And in some situations, that is definitely the right approach. It definitely makes sense to introduce abstractions, to consolidate things, to, for example, develop a NuGet package for a library which represents a common infrastructure concern, which is going to be used consistently across all of your different services and all of your different projects. But other times, that path only ends up leading to heartbreak, to pain, and frankly, to painting yourself in a corner. Because the moment you end up introducing an abstraction between two different pieces of code or two different objects or something like that, you have now coupled these two things together. They're no longer able to truly grow and diverge as the requirements, as the project, and as the needs require. I can give an example actually from a previous position working with the intelligence community to track nuclear material across the globe. We had part of our system, we were required to track nuclear material across multiple different types of buildings or structures or things like that, all of which had multiple of different requirements and multiple different use cases and different scenarios. And very early in the project, we abstracted that very far all the way to the concept of a location. And over the course of our project, we ended up finding ourselves having to more and more make parts of that location object virtual, having to open it up a lot more for modification for other different, more specific types of locations. And coming back to thinking in terms of the organization, different locations were managed by different parts of the organization, by different departments within the organization. And so if we were to ever introduce a bug in that abstraction of a location, then we ended up impacting the organization as a whole, and not just the one area of the organization which actually ended up requesting that change. So I always encourage people to question the urge to invent, and I use that term very specifically, invent abstractions. If that abstraction is not part of the domain language of your domain experts, then you're creating something as a developer brand new that may not necessarily be reflective of the problem domain, and may actually end up causing you a lot more heartbreak down the line. The next lesson is to defer decisions to the last responsible moment. And I say the last responsible moment because there is going to be a time in your project timeline where you have to do something. You have to figure something out. You have to solve a problem. A great example for this that came recently in one of our microservices was figuring out what type of data persistence medium we were going to use. Would it make sense for us to use a SQL server? Would it make sense for us to use maybe something NoSQL like Cosmos DB or MongoDB or something different? So instead of, at the very beginning of the project, sitting there and racking our brains about what data persistence medium to choose and what the form of our data was going to look like, what the structure of the data was going to look like, how best we were going to query it, and things like that. We said to ourselves, let's take a moment. Let's abstract this away. Let's abstract away our repository. Let's just make an interface. We can create a stand-in for the time being, which frankly would just write to files or write to the logs or to return an already composed object, and we'll figure out the rest down the line. So as we developed the application and as we began to see the structure of our objects, the structure of our domain model, how it was getting queried, and all of that other stuff, we were able then to determine, hey, SQL Server is perfect for us for this. The way that this data is being queried, the way that we see the future kind of coming for this type of data. No SQL doesn't necessarily make sense for us. And so a SQL Server database is the best. And because we abstracted that away and we developed to the abstraction, we developed to the interface of our repository, when we did decide on the data persistence medium, we were then able just to plop in a concrete implementation of our repository, which used SQL Server, and everything else worked fine. All of our other efforts were not impacted by that decision, and we were able to continue working on many more important aspects of the system and bigger decisions of the system than sitting there racking our brains about what type of data persistence medium or what type of storage we should end up using. That actually ends up leading me into my next lesson. Remember that practicality trumps purity. As software engineers and as analytical thinkers and as technology professionals, we sometimes get caught up in intellectual or technical purity and say to ourselves things like, well, a microservice should own its own data. It should have a database that's only specific to that microservice, and that microservice should only interact with that database and not any other pieces of data or anything else like that. And while I tend to agree with that, in this particular example, while I tend to agree with the idea that a microservice owns its own data, and that if I was to create a shipping microservice, that I would have a shipping database with only tables in it which represent shipments and the items in the shipment and other things like shipping rates and things like that. The fact of the matter is the business landscape and practicality ends up trumping a lot of that intellectual purity. The example that I can give, or the example that I can relate back to, is when we began looking at the pricing for our databases, and to be able to have each microservice have its own database and to work with only that database alone, we found that the costs were actually rather large. Each database itself incurred a specific cost. And given the amount of microservices that we were going to be developing, given our plan, we were going to be incurring those costs 5, 6, 7, 8 times over the course of a month. And when you're a startup like Hunter-Killer, frankly, cost matters. Business value and business practicality matters. And so sometimes you have to put that intellectual purity to the side, and you have to think to yourself, ultimately, what is practical? What's going to work best for the business? So in this example, instead of having each microservice own its own database and have that database only contain database tables and things like that that were specific to that service, we actually ended up deciding to create one database that all of the microservices share. We did that, by the way, fully aware that we are now coupling these microservices together at a database level, but given the cost, we were very much willing to assume that risk. Taking a completely other direction now, one of the other lessons that we've learned is automate what you can. Frankly, automate everything that you can, from things to code formatting and styles using tools like StyleCop or FXCop or Prettier if you're on the JavaScript side, to automatically setting up monitors using tools like Site 24/7 and New Relic, which can end up actually tapping into your cloud ecosystem and automatically adding monitors for new services which have been created. Automate everything you can. And the reason why is because the computer is going to do it more consistently. It's going to do it better. It's going to do it faster. It's never going to forget. It's never going to say, you know what, I've got too much work to do. I'm just going to leave this be and we'll get back to it later. Anything and everything that you can automate your software development environment, your dev environment, your QA, your production environment, your cloud ecosystem, anything and everything that you can automate, do it. It will save you time. It will save you money. It will be more consistent. You will have more time to focus on the things that matter. For the things that you can't automate, though, coming to our next lesson, simplify what you can't automate. So this lesson came up with regards to our logging infrastructure, the logging that we ended up putting in our microservices. Logging is not necessarily something that you can automate. Microsoft has made abstractions for logging in .NET Core very easy. You inject ilogger, ilogger.log, or log exception, log error, log warning, and those will send to your logging framework or logging repository anything that you put in there. So now logging is simple. It's a first-class citizen, but parsing those logs is not necessarily simple. Not a developer can put a logging statement into a piece of code, but when they actually try to go and find those logs and to trace what was happening for a specific payload or a particular request, if you haven't made querying your logs simple, you're not going to really, frankly, get any value out of your logs. So frameworks like Serilog, which is very popular in the .NET framework and almost kind of become one of the de facto standards for logging, provides the ability to add context to your logs, to be able to provide different pieces of information within different using blocks or within different scopes, to be able to add context and to be able to add important information to your logs, which will allow you to more simply search and query them and get value out of those things. So anything that you can't automate, make it as simple as possible to use. This actually ends up coming back to the framework design guidelines that I talked about. Help your developers fall into the pit of success. Help anyone on your team, frankly, fall into the pit of success. Have your DevOps team create templates for your resources that could be used by Ansible or Terraform or things like that to simplify the cloud provisioning process. Think about your users and how I can simplify the front end, or I can simplify the steps in a process to make it easier for them to be able to do something. Finally, and we're coming back now to the actual microservices of it all, the actual breaking up of this monolith into a microservice and deploying it. Have a bulletproof transition strategy. Make sure that as you're breaking up this monolith, as you're carving pieces off of it and putting and creating services out of this, that you have walked through how to cut over from the monolithic part of your application to the now new microservice. Create checklists, create steps, make sure that they're well documented, that they're well understood. Our first microservices deployment, the first deployment where we took a piece of our e-commerce system and broke it off into a microservice and then deployed that microservice to production, actually ended up going seamlessly because we had taken the time to document all of the steps that needed to be done in order to do it, from the littlest piece of detail of put this value in this box, check this button, make sure to check this monitor, things like that. That way, if anything were to go wrong in the transition strategy, or anything were to go wrong with the transition, you're not leaving it to chance. You're very well aware of what's going to end up happening, how you're going to end up cutting over from your monolith to this large microservice. Finally, the last piece of advice that I can give, or the last lesson that I've learned, is to monitor everything. Tools like New Relic, Site 24/7, Azure Application Insights are invaluable to monitoring the health and the performance and the wellness of your application, and to give you a wonderful insight or notifications when something is going wrong. Taking a monolith and breaking it into microservices is a large endeavor. It takes a lot of buy-in from a lot of people, many of them not technical, in order to walk this road. And the moment that something ends up going wrong, and the moment that somebody else makes you aware of it, is the moment that trust has been eroded in this transition and will make your transition even more difficult. So by being proactive, by having monitors, by monitoring everything, by being alerted as to exceptions, or dead lettered messages in your service bus message queue, or anything like that before other people become aware of it, is invaluable. Not only for the fact that you will now go from being reactive to proactive, but because you're also able to manage the expectations and the concerns of the people who have bought into your transition. So when somebody were to come to you and say, the website's down, or this part of the site isn't working, or this system is broken, you can say to them, we are already aware of it, we are monitoring the situation, we are researching it, we believe this is the root cause, and you can show to them that their trust in you, their value, and the process or the migration from this monolith to this microservice is valuable and in place and being handled well and efficiently. So just some resources that I'd love to share. A couple of these are books which I've already kind of mentioned. The first one is eShop on Containers. This is Microsoft's e-commerce system that has been built on top of microservices running and their containers running in Docker. This is an extremely valuable reference architecture for anybody who is interested in microservices. This ends up touching on so many best practices and tools and technologies that I encourage anyone and everyone who's interested in walking the path of transitioning from a monolith to a microservice to take a look into. This will touch on things like domain-driven design, CQRS for command query responsibility segregation, for developing your APIs and making sure that commands which change the state of the system versus queries which will pull data out of the system run fast, efficiently, smoothly, and are separated in a way that they can grow and evolve together. Other best practices like item potency and unit testing and functional testing and all of that great stuff that we aspire to as developers when we're taking on a large project. Other books like Building Microservices by O'Reilly Press. I love it because it's got honeybees on the front, and they are building their little hive. To the Clean Architecture and Clean Code books in the Software Craftsman series by Robert Martin. These are wonderful books that help you design clean code and clean architecture that as you walk this transition and as you end up giving your code out to other developers or to transition it to other people to support, they will end up thanking you. They will end up not having to go through pain and frustration and trying to figure out what the heck you are actually doing, because it will be clean, well designed, well understood, and very easily maintainable. And Software Requirements, which is a wonderful book on how to craft and expose software requirements from internal stakeholders, which is invaluable in understanding what exactly are we going to build for this microservice? What are the needs of a particular piece of our organization, and what does this service need to do in order to help them do their job or meet their goals? So with that, I'm going to open it up to questions. I apologize. I ended up speaking for a lot longer than I thought I would. We've got about 3 minutes left. Feel free to raise your hand if you have questions, or even put a question in the chat, and I would be happy to answer.
Awesome. We have one question on Discord from Enough Stuff. He says, I have a hard time understanding why microservices would be needed on an e-commerce site with so few products. What are recommendations about when they become practical? Number of development teams, etc. Like how to avoid over-engineering?
Oh, that's a great question. Again, my answer is kind of, it depends. Our e-commerce system, yes, we have so few products. By the way, the screenshot that I had only had just our premium experiences. We have a far bit more and merchandise and things like that. That aspect of the e-commerce system is not necessarily the biggest culprit. One of our biggest culprits that I did not mention is our subscription management service, for example. Every night will end up renewing customers' subscriptions, will push data to our shipping platform or our shipping provider, and create orders and payments and invoices and things like that. That actually puts a lot of strain on our e-commerce system. Some situations, even on a light load, we're looking at about 3,000 to 4,000 orders. And so while our e-commerce system is every night at a particular time busy kind of dealing with that part of our system or of our traffic, other parts of the e-commerce site are suffering, are not being able to fulfill requests and things like that. So I think to get to kind of the heart of your question, the answer is it depends. You really have to look at the traffic. You have to look at the strain on your system, resource utilization, CPU utilization, things like that.
Well, that is about all the time we have. Thank you very much for that insight into microservices.